Take the second case, n is even. So f dash of n plus 1 by 2 plus is equal to limit x approaches n plus 1 by 2 plus f of x. So f dash of x. So this is nothing but limit x approaches n plus 1 by 2 plus pi x cos pi x plus sin pi x. So this will be n pi plus pi by 2 cos n pi plus pi by 2 plus sin n pi plus pi by 2. Now since n is even, suppose you take n equal to 2, cos 2 pi plus pi by 2 is cos pi by 2, 0. Cos 4 pi plus pi by 2 is again cos pi by 2, 0. So the first one will be 0. Plus when n is even, sin n pi plus pi by 2. Suppose you take n as 2. Sin 2 pi plus pi by 2 is sin pi by 2. So that is 1. If you take n as 4, sin 4 pi plus pi by 2 is sin pi by 2, 1. So when n is even, sin n pi plus pi by 2 will be 1. So that means, therefore, f dash of x is greater than 0 when x is greater than n plus 1 by 2. F dash of n plus 1 minus is equal to limit x approaches n plus 1 minus f dash of x. So this is limit x approaches n plus 1 minus pi x cos pi x plus sin pi x. So this will be n pi plus pi cos n pi plus pi plus sin n pi plus pi. Since n is even, suppose you take n as 2, cos n pi plus pi will be cos 2 pi plus pi, so cos 3 pi, which will be minus 1. If you take n equal to 4, cos 5 pi is what? Cos 4 pi plus pi, which is cos pi, again minus 1. So this is going to be minus 1. Therefore, this will be minus of pi into n plus 1. Plus, when n is even, say n equal to 2, sin n pi plus pi will be sin 2 pi plus pi, sin 3 pi, that is 0. So when n equal to 4, 4 pi plus pi, 5 pi, so sin 5 pi is 0. So when n is even, sin n pi plus pi is 0. So the whole thing is less than 0. Therefore, f dash of x is less than 0 if x is less than n plus 1. We have already shown that f dash of x is greater than 0 if x is greater than n plus 1 by 2. Therefore, f dash of x is equal to 0 in the interval n plus 1 by 2 to n plus 1 when n is even. So we have shown that f dash of x equal to 0 in this interval n plus 1 by 2 to n plus 1, irrespective of whether n is odd or even. Therefore, f dash of x vanishes in the interval n plus 1 by 2, n plus 1 at a unique point. Now, it is very clear that this interval n plus 1 by 2 to n plus 1 is a subset of interval, open interval n, n plus 1. So, we can choose option C, provided we are able to show that f dash of x does not become 0 in the interval n, n plus 1 by 2.